Again, we have a function. The acceleration in meters per second, oh, that's just the unit, of a radio-controlled drone moving in a straight line during a particular time can be modelled by this function. So y equals 0.2 t plus 0.3 root t. And it's saying that's the acceleration. So that's the formula for the acceleration. So maybe you want to write that instead of y. So if you fill t into that formula, you'll get out your acceleration, where t is the time in seconds. If the speed, well, I don't have a formula for speed. So I have a formula for acceleration. How do I go from acceleration to speed? Well, hopefully, when we were doing differentiation and integration, you understood that, distance, if you have a formula for distance, it differentiates to speed. If you have a formula for speed, it differentiates to acceleration. So if we are down here and we have a formula for acceleration, we need to integrate to get back to speed. So I need to integrate this in order to have a formula for speed. I need to show them even just that I understand that I need to integrate. So we're going to integrate I'll do it over here, 0.2 t plus 0.3. Now root t is t to the power of a half. So if I integrate, I end up with, I'm going to add 1 to the power, divide by my new power, plus I'm going to add 1 to the power. So now we're on 1.5, divide by my new power, and then plus c. Let's clean that up. 0.2 divided by 2 is a 0.1 t squared. And then 0.3 divided by 1.5. You can throw that into the calculator. And I get 0.2 t to the power of 1.5. You could clean that up, but I don't really feel the need to. I think that's actually quite clear. Plus c. Now, we're always going to try and find the value of c if we can. That's just rough work. So have they told me anything else? They've told me if the speed of the drone after 1 second is 1.4. So now we have our formula for speed. Let's fill into it. When the time is 1, the speed is 1.4. So 1.4 in for the speed, and the time is 1. Sorry, that's 1 to the power 1.5 plus c. So let's work this out. We have 1.4 is equal to 1 squared is just 1 times that is 0.1. And then we have 1 to the power of 1.5 is 1 plus 0.2 is 0.2 plus c. So it looks like when we bring everything over, c is 1.1. Okay, so my actual speed formula, here it is with my plus c, my unknown, but I've just used the information in the question to figure out what the unknown is, as we always try and do. If we can't, we just leave it as plus c. So I was given the acceleration formula. Now I've integrated fully and worked out my speed formula. Find its speed after 5 seconds. That's okay. Anywhere I have a t, throw in 5. And again, you're just literally just throwing that into the calculator. So we have 0.1 times our 5 squared plus 0.2 times our 5 to the power of 1.5 and then plus 1.1. Give my answer to one decimal place, we have 5.8. So the speed is 5.8 and meters per second is my unit. Okay, next bit is differentiating from first principles. Make sure that you have your formula. Now it's not in the log tables, so it is something that you have to either understand or learn off. So they want me to differentiate from first principles. The function f of x is equal to minus 2x squared plus 3x minus 7. So my formula for first principles is f of x plus h minus f of x all over h, and we get the limit as h tends to 0. That is my full formula, and I eventually will fill in every piece of that, but it's good for the examiner to know where I'm starting from. So we have f of x. F of x plus h means anywhere I have an x, I can replace it with an x plus h. So I'm going to go down here maybe to a little bit of rough work. F of x plus h is, again, anywhere I have an x, I'm replacing it with an x plus h. And then just work that out bit by bit, multiply it out, square it out. A minus 2x squared plus 4x, no, that's a minus 4xh, plus, no, minus a 2h squared plus a 3x plus a 3h plus a 7, minus a 7, apologies, minus a 7. Okay, so there's f of x plus h. So what do? I get f of x plus h and I subtract f of x. So here's my f of x plus h. And I need to subtract my f of x. Okay, that minus is going to affect everything after it. So I have minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 7 plus 2x squared minus 3x plus 7. This cleans up a bit, which is nice. And I end up with a minus 4xh minus 2h squared plus 3h. So I've just done the top line there. I got f of x and I subtracted, I got f of x plus h and I subtracted f of x. I got that. Now divide by h. So you take the h out in common and you simplify and you'll be left at minus 4x minus 2h plus 3. Now we're getting the limit as h tends to 0. So as h gets really, 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 really infinitely small, what would I be left with? Well, 2 times something really small is really just 2 times nothing, plus the 3. So that's my f dash of x from first principles. Is that correct? Well, quickly just do it the fast way. A minus 4x plus 3. Yeah, that's definitely right.